Uh, Hi, my name is Octavio, and today we're going to talk about one of the most beautiful phenomena that can actually happen on Earth and in more planets, and that's the Northern Lights, or also called as Aurora Borealis. So the things that we're going to talk about of Northern Lights is going to be a little bit of history of the development of research of this phenomenon. Some of the characteristics of the Northern Lights, such as the color, the sound, and then we're going to go to a more physical point of view by talking about the magnetic poles of on Earth, the interaction that has with the sun, this phenomenon, and finally how is made with all these things that we will talk across the whole video. So, history. Northern Lights were actually a very unknown phenomenon at the beginning of their discovery. They're related to cultural thinking in many countries, especially in those on the north or in the south, where Northern Lights can be created. There's also a spiritual thought about Northern Lights. They have some connection with the spiritual beliefs. There is also some different behavior in nature related with Northern Lights, such as the encounter with, for example, whales that go out of the sea when Northern Lights are happening. But we're going to focus on this man. His name is Christian Birkeland. He was born in 1867 and passed away in 1917. Christian Birkeland was the first physicist who thought that Northern Lights were related with magnetic poles on Earth and with magnetic poles created by the sun. Before Christian Birkeland and his theories, there was a belief that Northern Lights were created by the interactions with just sunlight and air. Christian Birkeland worked with this machine. It is called a Tyrrella. The Tyrrella is a box full of an empty space with a magnet in the form of a sphere that is going to represent the Earth or any body that has a magnetic field on it. What Birkeland made was he injected a beam of electrons through the box, and he actually was able to see that the beam of electrons was moving towards the sphere, towards its magnetic field. So that's where he proved that Northern Lights are related with a magnetic field of Earth and with the interaction of some phenomena that happens with the sun. Now, here are some properties of a Northern Light. First of all, we had to talk about the color. Northern Lights can have different types of color. It depends on the interaction with certain gases on the atmosphere, such as oxygen or nitrogen. And with the interaction of light and the magnetic fields with the sun and the earth. There's also an interaction with these gases that ejects photons into the into the atmosphere, which produces this phenomenon of light that we can see. The type of color also depends on the altitude of where the phenomenon is being created. So we can have there are mainly four colors on a northern light. There are some that are red, that has an interaction with oxygen into very high altitudes. Then there is the green one, the green color, that is also an interaction with oxygen, but in lower altitudes. There is a blue one that is the same as the red one. It's on a very high altitude, but this time it has an interaction with nitrogen. And lastly, we have the purple color, or violet, that it has also a nitrogen interaction with nitrogen into the atmosphere, and it has a little bit of lower altitude. Another type of properties that a northern light can have is sound. It's not always there, but there are some special occasions where a northern light can actually generate sound. So here's an example of what a northern light sounds like. Now, what happens when that makes these sounds with northern lights? It's a very simple principle. It has to be some special conditions in the atmosphere, so there can be a sound when the northern light is happening. The first one is that it has to be a very low temperature, below 0 Celsius degrees. This creates a phenomenon where at certain altitude, there's going to happen a phenomenon where the higher the altitude gets, the higher the temperature gets also. So this makes that some particles go up and some energy particles stay down also. And we're going to have here what is called a magnetic storm, where it's going to get a lot of charges on the top. And when the storm is actually happening, the magnetic storm happens, what it happens is that there is a discharge of these particles. They're going to discharge down. So the sounds that you can hear from a northern light is this action, the discharge of charges created by the magnetic storm. Now let's talk about some more physical properties of a northern light that has to be related with magnetic poles. So here we have the magnetic poles of the Earth. We have to understand that the magnetic pole of Earth is totally different to the geographic poles that we have of our planet. Magnetic poles are from here, from a very small difference of what the geographic north and south pole of the Earth can be. To understand a little bit more easier the theme about magnetic poles, we can refer as to the Earth as a giant magnet. So it's going to have its south pole and its north pole, and it's going to create on both sides a magnetic field, which is going to be called a magnetosphere. And as we can see here, is one of the many spheres that protect Earth from outside particles that can damage life. Another concept that we have to understand is solar wind. So what is solar wind? The sun's activity is not always going to be stable, and there's going to be some times when, especially on the crown of the sun, there's going to be some blasts of energy are not going to stay on the surface of the sun, but they're going to get beamed up to the outside. Those beams, or what we are going to call solar winds, is an amount of magnetic force coming to a place. We have here a magnetic force, a magnetic field coming out from the sun and being directed outside of the surface of the sun. This blast have a magnetic force, but they're also going to have isolated particles such as electrons coming from this wind. They're going to be electrons, protons, neutrons, etc. So what is going to happen is that this solar wind is going to face the magnetosphere of the Earth. So how does the solar wind and the magnetosphere interact? First of all, magnetic fields from the solar wind and the magnetosphere can get combined. So we can have here a magnetic field of sun and the one of the Earth. And if the magnetic force of the solar wind is too strong, there can be a combination of this. What the magnetosphere is going to do is going to carry or push all this force coming from the sun, from the wind, and is going to drag it outside of the Earth's surface, and is going to be redirected where the magnetic field is more weak, which is actually the north and the south pole. So that's actually one of the main reasons why we can see northern lights or southern lights just on the south pole or the north pole of the Earth, because of the magnetic field of the planet. So the magnetosphere carries the wind to the polar fields of the Earth. There's going to be a release of energy, and the magnetic field of the wind of the storm, magnetic storm that is created from the sun, is not going to affect that much the surface of the Earth, because the magnetosphere is protecting us from that. But the release of energy is what is going to create this phenomenon called northern light. That release of energy is what we are actually seeing when a northern light appears. And that is another phenomenon that is called a magnetic reconnection. So an easy way to understand what magnetic reconnection means, we can recall it to a rubber band. we can see this rubber band as our magnetic fields. So when we have magnetic fields coming from here, from the solar wind and from the magnetosphere, the magnetic fields are going to get together, and it's like we are going to stretch the rubber band. It's like the magnetic fields are going to stretch until a moment where there is going to be a rupture, and there is going to be a release of energy, just as a rubber band. When we stretch the rubber band to a point where it cannot be stretched more or it's going to break, when we release the rubber band, it's going to expand and it's going to release a lot of energy. So here we can actually see an example of an animation of how the magnetic reconnection works. So as I said, it's like a rubber band. The magnetic fields are going to stretch until a point where it's going to break, and there's going to be a release of energy from the stretching of the fields. They're going to break, they're going to release energy, and that energy is what we are going to see in the Northern Lights. So, to finally conclude, we have to say that Northern Lights is not a Earth-only phenomenon. It's a thing that can actually happen on different planets or objects or celestial objects that has a magnetic field. We know, for example, here in Jupiter or in Saturn, that there are also these types of phenomena being created. This can be also because of the magnetic fields of the planet or magnetic fields from other objects that are very close to the planet. We also have to know that this phenomenon is not always going to be the same size. There are it's going to depend on the force of the magnetic storm that is created from the sun and the repulsion from the magnetosphere. So the size of the magnetic force and the energy that is being released is going to be the size of the Northern Light. It is also important to know that even though it's one of the most beautiful phenomena that can actually happen with these types of interactions with the sun, we are talking about magnetic storms that the sun is sending to the planet. So the magnetosphere can actually repel, but there's going to be some times where the magnetic field is way stronger than the magnetosphere. So there's going to be some entrance of this magnetic storm, and well, it's not going to affect directly to the Earth, but that magnetic disturbance can actually affect satellites that are very close to it. And well, by affecting the satellites, there can be a disturbance with lights or technology that is here on Earth. So it's at the same time a very beautiful phenomenon, but at the same time is a very dangerous one if we as humans, as researchers, don't get enough information about this phenomenon. And well, here are the references. And it's also good to know that there are many stations of physics, like in Alaska, Canada, Sweden, that are specialized on studying Northern Lights, and well, there is a lot of information that you can actually find about the topic. So it's very interesting to know that. And that'll be it for this project. Thank you very much.